will sometimes just abbreviate as PIC. Just to add to the fun, some textbooks won't call it a perfectly inelastic collision, they'll just call it an inelastic collision. For the textbooks that call this an inelastic collision, well, they have three classifications here. There's one where the kinetic energy does not change. There's one where there's a loss. The change in kinetic energy, they lose kinetic energy but don't stick. And then a loss of kinetic energy and they do stick. So if the textbook calls this inelastic, they would call this one elastic and this one perfectly elastic. However, other textbooks call this middle one inelastic, and this one's perfectly inelastic.
That's annoying.
And they just call this one elastic. So if there's an elastic collision, if you're looking at the textbook or some website and they call it an elastic collision, which one are they talking about? Are they talking, pardon?
The first.
Maybe. You have to sort of read through to figure out which one they mean. So, in an attempt to make sure that there's not a question about which one it is, I adopted a third method. I call this perfectly elastic, and I call this perfectly inelastic. This middle one, I call imperfect.
That makes sense.
It came from a student who suggested it, and I liked it. There's one other classification, which textbooks and I have different terms. If you gain kinetic energy without an explosion, so two objects collide, energy somehow comes out of nothingness. Textbooks tend to call this impossible.
Because that goes against energy conservation.
Yes, it does. I call it Flubber-esque.
Okay.
If you've not seen Absent Minded Professor or Flubber, personally I recommend Absent Minded Professor, but each to his own. You can consider it a homework assignment.
She
All right, so I'm going to have a perfectly inelastic collision here. They're going to collide, they're going to stick together. So now it is a 15 kilogram mass.
Okay.
And I want to know how fast is it going, or what is its velocity after the collision. So the way we do this, it's a collision. So what you should do, what I would like you to do, is that if there's a problem with a collision in it, you should immediately think conservation of momentum. So I have a collision here. What's the first thing that you think?
Conservation of momentum.
There we go.
Yeah.
That was more unison than I was expecting. Thank you. So we have to figure out what is the total momentum beforehand. So let's figure out the momentum of this. PA initial. What is the initial momentum of object A?
The initial momentum of object A. It's 10 times 3, 30. Do we have to do coordinate axes here? Or like at least to know which is positive and which is negative, like which direction?
These are vectors. Yes, you do.
Can we put positive as this way?
Okay. It's one of the few times someone picked that out before we got to it. It is critical. 30 what? What are the units?
Meters squared per second. Meters.
Where'd you get the extra meter?
Meters squared.
Meters
Because
per
it's
second.
mass.
It's just
Oh
meters per
wait,
second.
I'm sorry, I lied. It's newtons, right?
No.
Ah,
Is it
dang.
just meters per second?
It's kg meters per second.
So kilogram meters per second?
Yeah,
Yes.
Oh,
okay. I have to write that down every single time.
And there should properly be a dot between the kilogram and the meters.
Is there, I mean, that makes sense, but is there a KGM that's,
No, but I have seen some textbooks use GM for gram.
why?
You don't know.
Is that's just G,
5 times.
and that's not even physics.
Yeah. I do. All right, now let's say that kilogram meters per second is too much to write. You're just feeling, oh, God, do I really have to?
Yeah,
Well,
that's what I'm saying.
notice that the change in momentum is equal to this impulse here, so the units of momentum should be the units of impulse, which is just a Newton second. So I could also write 30 Newton seconds, which some people prefer.
Ah, sorry, I was almost.
Newton's time seconds, not divided?
It is times.
Okay.
And now some people might look at that and go, oh, God, it's so much to write.
What the heck? How is it going?
You have a third alternative. Make up a unit.
Oh.
Now, the big rule when you're making up a unit is you can't use something that's already being used.
So, don't, pretty much.
Well,
What about Z? Would that work? Is there any Z?
I'm not familiar with any unit that's Z, not that we would use. Z is fine if your name is, let's say, Nelly, and you want to honor yourself and you create a unit N. Don't, because that's being used for Newtons.
What about R?
That's for
Or
like.
B? Or E? What?
No, there are a number of letters that, I typically use D. The reason I picked capital D is because Rene Descartes was, as Newton was doing his stuff with forces, Rene Descartes was looking at momentum. Someone made a suggestion of B, let's say Becquerel, it's not, I think it's a different guy. But if you're going to make up a unit though, you need to define it. So up here, I'm just gonna write 1D. 3 lines meaning equal by definition. Equals 1 kilogram.
Is that not just congruent? Equal by definition. Is that not just congruent?
No, congruent means that the lengths are equal or the angles are equal. The measurement is equal.
Okay.
So if you define it, then you can write as the answer.
Got it.
Now, if you write it at the top of a quiz or a test, I'm assuming like for computer science, it is a global variable and it covers the entire test.
Okay.
If you want to do it for a particular problem, you can just write that in a particular problem. It would be in computer science
So
language.
one
a local
dimension is
variable.
always just one?
No, that's 1 Descartes is equal to 1 kilogram meter per second.
Okay.
But that's
So,
the problem with using a capital
It's
D.
not 30 dimensions, it's 30 Descartes.
Yes.
Oh, okay. How do you spell that? Like Descartes with an E on the end?
This.
Oh, oh god, it's French.
Is there an S on the end?
Yeah, I think so. For all his international.
That's, you know,
All right.
French.
Now, some students hate making up units. The unit that you make up doesn't even have to be a letter. Some have made up some squiggles just because it's, just so long as it's unique. You know, it won't confuse it with something else, and you define it. All right, so what is the momentum of B?
Negative 35D.
What is the total momentum before the collision?
the big P?
Yep.
Okay.
Total momentum before the collision is just you add them together. You add them like vectors. I got one going in the positive direction, one going in the negative direction. The net result is 5 in the negative direction. What's my total momentum after the collision?
5D.
Simplest.
What?
Is
Why
it
not?
like a number problem or a units problem?
Her issue is with the direction.
No, positive
Negative
5D. It has to be positive 5D, no?
Why would it be positive?
Would it not be?
Wait,
negative?
was change of PA equal to change of PB, or was it change of PA equals negative change of PB?
Negative.
So why isn't it positive 5D?
Because this is a total here and not looking at the individuals.
So are we doing PB minus PA?
No, what,
The answer's
All right.
negative 5D.
the equation, what you just mentioned with the delta PA equals negative delta PB.
Mhm.
If we look at the change of momentum of object A, it is going to be the negative of the change of momentum of object B.
Oh.
But I'm talking about the total momentum here of the system.
Yeah.
If we start out, if before the collision we have negative 5 units of momentum before the collision, what is the total momentum after the collision?
5D.
I think Stephanie said it? No? Ava? I heard somebody say it.
I said negative. I said negative 5D after I guessed 5D. I don't understand why both of those
I
are
couldn't
wrong.
hear, I didn't hear you say negative,
I don't understand why it's negative though.
because it is negative to begin with. Is the question about why is this negative?
Yes.
Because I have 30 plus negative 35.
Oh, that's where the thing. I was looking at the top.
Oh.
I was doing like 10 kg minus 5 kg. I was like, what's wrong with this?
No, you look at the momentum at 30, negative 35, the total is negative.
Oh, okay.
I have asked this on tests before, where I set it up and I give them the initial condition, I say, what's the total momentum before the collision? Part B, what's the total momentum after the collision? And a shocking number of people miss that.
Really? I would love that question on the test.
You would not.
You know, it's the kind of thing where I'm going, oh, here's an easy one, that's a gift for people. And people are jumping through hoops trying to figure out how to do that. Not too many. All right, so my total momentum after the collision, so P final is equal to negative 5 Descartes. And that's going to be equal to the mass final times the velocity final. So I have negative 5 is equal to 15 V final. So after the collision, they will be moving to the left at 1/3 of a meter per second.
Okay.
A little under 1 mile an hour. Questions?
No.
So the change in momentum is A plus B, but A is 30 and B is negative 35. That's why we get the negative 5P.
It is negative 5 because we have 30 plus negative 35.
So that's what I said.
You threw the word change of momentum in there somewhere.
Because we're doing PA minus PB.
I
That's,
did not do, I did PA plus PB.
Yeah.
I'm adding a
Okay.
negative. Mathematically, it's like you're subtracting, but from a physics point of view, you're adding a positive and a negative number.
okay.
Okay.
So it's not a change in momentum.
It is not. If we want to look at change in momentum, the change in momentum of A would be PA final minus PA initial. I know initially it's 30. My final is going to be, well, it's traveling at negative 1/3 as a mass of 10, so this would be negative 10/3. So I have negative 100/3. The change in momentum of B would be PB final minus P, the initial, which is going to be -1/3 times 5, so -5/3, minus -35.
So if PI is -5 and PF is -5, then that conserves that upholds the conservation of momentum. Okay.
It sounded like you came to some conclusion yourself?
Yes.
Okay. Notice the change of momentum of A is the negative of the change of momentum of B. Thus, the total change is 0.
What's the total change is 0? God.
We are about to step into the exciting world of, we got this, and then we can get into the perfectly elastic collisions, which is a lot more fun. And I will tell you, on the next test,
Oh my god.
there will be a perfectly inelastic collision problem, and there will be a perfectly elastic collision problem. I'm telling you right now. I've done
Will there
this
be any input?
course after course where I tell them, there will be one of those, there'll be one of each type on that test. And I'm still shocked to find the number of blanks I get. When you're told ahead of time.
Is it, are we told if it's perfectly elastic or inelastic?
Yeah.
Or do,
I'll tell you.
oh.
I was taking a senior level physics class and the teacher said, this question came up, said, this particular question will be on the test. And so we tried to work it out on our own, but there's plenty of warning. It's like a week before the test, and there were a group of us who stayed afterwards and he worked through the problem for us. So we knew how to do it. We took the test, in the behold, that problem was on the test. I got it right because I watched him how to do it, watched how he did it. And then he turned, and then after the test, he said, I did tell you this was gonna be on the test, right? I said, yeah. He goes, yeah. Just shocked at the number of people who did not get it. So, I will be shocked if people do not get it. There will be a perfectly inelastic collision problem on the test. There will be a perfectly elastic collision problem on the test, one-dimensional. And on that cheerful note, have a wonderful day, and I will see you tomorrow. Bright-eyed, Michigan. Pardon?
I was saying you as well. You should have a great day too.
Well, thank you.